6th grade lesson 11.3 is surface area of prisms. And the surface area, remember, is if I were to cover the outside of a three-dimensional shape. And we had talked about in the previous lesson what are some steps you can use to find the surface area of a prism. Step 1, what shapes are there? Identify what shapes you're looking at. Step 2, what's the formula for the area of those particular shapes? And step 3, calculate that and add everything together. Quick refresher on all of the formulas that we know. And there is the area formulas that we know for parallelogram, which does include squares and rectangles, base times height. For triangles, area is 1/2 times base times height. And for trapezoids, area equals 1/2 times the sum of base 1 plus base 2 times height. If you do not already have those written down somewhere, write them down. You may just want to put them at the top of the guided, of the show what you know pages and stuff, just so you have them handy. And this lesson is really just kind of continuing on from what we were already doing in the last lesson. We have Alex designing wooden boxes for his books. Each box measures 15 inches by 12 inches by 10 inches, 15 by 12 by 10. Before he buys wood, he needs to find the surface area of each box. What is the surface area of each box? So what are the shapes that we will be looking at? What are the shapes of each face? Those are all rectangles. And what are the dimensions of each face? Well, we have a 15 by 12. Then we have a 10 by 12. Then we have this 10 by 15. Those are the ones we have. And they went ahead and did the net for us. They laid out the net, thankfully, because you know how good at that I am. They even put the dimensions for us. Thank you. And they went ahead and labeled their net A, B, C, D, E, F, so that they have all of their shapes labeled out, make it easier. And they decided, okay, since I have all rectangles, the formula I'm going to use is base times height, or length times width. They wrote it down as length times width, I think, somewhere. Maybe they didn't write it down as length times width. Anyway, base times height and length times width mean the same thing on a rectangle and a parallelogram, so we were going with that. They went ahead and broke it down. Face A, face B, C, D, E, F. So you'll remember in the previous lesson I had kind of said, oh, well, we have 2 of these, and we have 2 of these, and we have 2 of these. Well, you could do it that way too. You can break it down that way too. But they're going ahead and doing one by one, and that's fine too. Whichever makes the most sense for your brain, do that. So they've already done the faces, the dimensions for A. It was 12 by 10. So 12 times 10 equals 120. The face for B, B is 10 by, this is 15 over here, so this is 15 over here. 15 by 10 is 150. Then we need to do the dimensions for sides for face C. C is this one. It is this dimension, which is going to be 12 because it's the same as this, right? 12 by this length, which is the same as this over here, 15. So 12 by 15. And we'd have to calculate that real quick. Maybe some of you know what that is offhand, but I don't. 180. Now I do. Okay. Face D is 10 by 15. That's 100. 10 times 15 is 150. Face E is 12 by 15. 12 times 15, which we now know is 180. And finally, face F, which is 10 by, that's the same as that, so 10 by 12. And 10 times 12 is 120. Once I have found the area for each of the separate rectangles that would fold up into a box, now I just add all of those faces together. So we have 120 from here, don't forget that guy, plus 150 plus 180 plus 150 plus 180 plus 120. And in addition, we can put them in any order we want. So if you wanted to line those up for easier addition, you could do that. as long as you don't forget any of them. And then do the addition. That's 10 plus 16 is going to be 26, 27, 28, 29, 30, 3, 4, 5, 6, 7, 8, 9. That is going to be 900, which means the surface area of the box is 900 inches squared. Area is to the second power. And that's how you do that. Step 1, what faces am I looking at? Step 2, what are their step 1, what faces am I looking at and what are their dimensions? Step 2, what formulas do I use for that shape? And step 3, calculate and add everything together. Okay, the next example is a triangular prism, and they went ahead and did the net. You've got the triangle and the base triangle and the top of the triangle there, and then unfolded you have these rectangles. I would look at this and just say, look, I have a triangle there, same as the triangle down here. Then I have a rectangle, rectangle, rectangle. So because the net might take me a while, I might just draw the shapes: triangle, triangle, rectangle, rectangle, rectangle. So they went ahead and did that for us. That's nice. We can even see the dimensions they gave to us, but if they hadn't, when I'm looking at my triangle, I know it's 5 with a length, the depth of the height of 12. I know I have the rectangle 10 by 13, and then I have this 10 by 5, and then I have this 10 by 12 or 13. So actually that's hard to see. So a lot of times it's easier to see this way, but thankfully we have the net there. Okay. So then they labeled them too for us: A, B, C, D, E. And so area of base A, remember that's a triangle. So we're using the formula for area of a triangle is 1/2 base times height. So 1/2 times 12 times the height of 5. I would do half of 12 first, which is 6, and then 6 times 5 is 30. Then we have face B, which is 5 times 10, which is 50. Then I have face C, that's this one here, 12 by this length, which is the same as this length, so 10, 12 by 10. 12 times 10 is 120. I have face D right here, which is 13 times 10, which is 130. I like these times 10s. That's very helpful. And that's all my faces. I do have this face that they didn't do, but it's going to be the same as this one, right? And so that's where they took into account that. They said, well, I've got 2 of those. I've got A and E, 2 of them. So I'll double that to take care of this and that. So that's why it feels like something's missing. They took care of it right there. So we're going to do the 2 bases times 30. Then we're going to add to it the 50 from right here, the 120, and the 130. Okay, as you know, the 2 times 30 has to happen first. That's 60. And then I will add everything together to get 360. So the surface area of the triangular prism is 360 inches squared. Now they say, well, what if I have a square prism? With a square prism, remember, in a square, all the sides are the same length. That's 5, that's 5. That's 5, that's 5, that's 5, that's 5, that's 5, that's 5, right? So I really am, and they laid it out for us, but I really am only looking at one shape. I'm just looking at that one area of 5 times 5, which is 25. I'm looking at that area 1, 2, 3, 4, 5, 6 times. So to find the area of each face, all of the faces are squares with a side length of 5. So the areas of all the squares are the same. Area of one face is 5 times 5, which is 25. Find the sum of the area of all 6 faces. That's 25 plus 25 plus 25 plus 25 plus 25 plus 25. And I know most of you are saying, oh, shortcut for repeated addition is multiplication. Can't we just multiply by 6 and be faster? Let's do that. 6, 12, 13, 14, 15. 150 centimeters squared. There is a formula, is what they're teaching us. This is not something I have memorized, just because I can throw it together pretty quickly that just this way. But there is a formula to find the surface area of a cube. It's S for surface area equals 6 times S for sides, lowercase s for sides, to the second power. That at sides to the second power is this part, one side times itself, gives us 25. So that takes care of that. And then you would multiply it by the 6 of them that are there. So if I knew this formula and I had this square cube that I needed to take care of, the only piece of information I need is what's one of the side lengths. It's 5. Okay, and then the 5 to the second power is 25, and then 6 times 25 will get me 150. So that's that. So really, that's all you're doing in this lesson is what are the shapes you are looking at and what are their dimensions? What formula do you use to get the area of those shapes? Add it all to calculate it through and add it all together, and you will have the surface area of that object.